Today we are going to see about the DC distributor fed at one end. Actually, the DC distribution calculation consists of there are three categories. One is distributed with the concentrated loading, with equal voltage, with unequal voltage. Then ring main distribution, radial distribution. We are going to concentrate about the concentrated loading fed at one end. Okay, this is a given example. A two-wire DC distributor cable AB is a 2 km long. Consider a AB length of 2 km long and supplies load of 100 amps, 150 amps, 200 amps and 50 amps situated 500 meters, 1000 meter, 1600 meter and 2000 meter from the feeding point A. So this is the actual feeding point A. Each conductor has a resistance of 0.01 ohm per 1000 meter. Calculate the potential difference at each load point if a potential difference of 300 voltage is maintained at point E. So we are going to solve this problem theoretically as well as verified with the simulation result. Now we have to start with the calculation. How we are going to arrive the solution? For the first step is we have to start with the diagram. A two-wire distributor AB is the length of 2 km. Then we have to note down the each point of the tapping current with respect to the length. For consider 100 amps tapped at 500 meter. Situated at 500 meter, we have to tap it 100 amps. Next again 150 amps, that is the length of 1000. Actually, from point E, the total length is 1000 for 150 amps tapping. Similarly, 200 amps tapping, that is the total length of 1600 from point E. So each current rating will be tapped from the length of point E. Similarly, 2000 meter from point E. You can add together all together 500, 600 plus 400. We can get 200 meter. That is the current rating of 50 amps. So this is actually fed at one end. The voltage rating is 300 voltage. Okay, for each and every session, for consider from A to C, the current rating is all the current will be flows through the section A to C. So 100 plus 150 plus 200 plus 50, then the total current is 500 amps flow through the section A to C. Then again 100 amps is tapped at the point C. Then again the remaining 400 amps flows through the section C to D. Then again at the point D, 150 amps tapped. Then the balance amount of current 400 minus 150, 250 amps is flowing the session D to E. Similarly, for 20 amps tapped from the point E, the balance current 50 amps flow through the session E to B. What is the ultimate need of to calculate the distribution? What is the each and every point? What is the voltage? In order to obtain where or which point the minimum potential, in order to compensate that potential, the aim is to find where the point the consumer get minimum potential. We have to compensate it. So that's why the DC distribution calculation is important. Next, we have to go for the solution. This is a single diagram representation of the distributor with the tapped currents. Okay. Now we have to calculate the resistance 0.01 per ohm per 1000 meter. Now we have to calculate resistance per 1000 meter of the distributor. Is this a two-wire distribution? 2 into 0.01, we can get 0.02 ohm. Similarly, we have to calculate the resistance for each section. Consider for each length, that will be converted into 1000 meters to the equivalent distribution. Say example 500 meter, we have to get equivalent to the 1000 meter. This is 0.01 per 1000 meter. We have to convert it into the required meter into the getting actual resistance value. we can get the value of resistance A to C section 0.01, similarly C to D 0.01, similarly for section DE 0.012, section EB 0.008. So referring this figure, the current in the various section of the distributor, how to calculate the current in the distributor based on the given current load or supplying load, where thereby we can able to get that. So next we have to calculate the potential for each and every point. What is the potential at point C? So what is the voltage at A minus drop in A to C, thereby we can able to get the voltage or potential at BC. VA minus IAC into RAC, thereby we can get the value of potential at BC. Similarly for the potential drop at the point D. What is at point D? We have to get the value of VC minus CD, the drop in CD. So VC minus ICD into RCD, we can get the value of BD, potential drop at load point D. Similarly, point E and point B, we can get the voltage 295, 291, 288 and 287.6 respectively. So this is the actual calculated value. We have to ensure that the calculated values we are getting actually correct or not, or we have to verify it using the simulation tool. The same structure of the DC distributor is simulated and calculate the each and every point what is the voltage. The ultimate aim is to find the minimum potential, where the point the minimum potential will occur. Here in this calculation part, we are arrived that the minimum potential will occur at the point VB. VB is the actual voltage 287.6. Now we have to use that arcade piece-based simulation software. We have to simulate the same circuit fed at 1.5 300 voltage. We have to use the voltage source, various resistance for each sections. There will be a series resistance are there. There will be a shunt resistance. There is no direct current loading sources are there in the simulation software. That way we can able to use the value equivalent to the resistance value. We have to convert the current rating equivalent to resistance value. We have to put it in parallel based on the current rating. 100 amps, we have to calculate the value of 2.95. Similarly, for with respect to this point, we have to calculate what is the resistance for this section. From tapping C point, what is the shunt resistance? From D point, what is it? Similarly, EB, we have to calculate the shunt resistance value, substitute that value, and after the simulation, we can arrive that solution. We are getting the value of point BC 295, what we are actually arrived in the calculation. The simulation is also we are getting the same result. So this is the way we have to conclude that we are calculated value is verified with the simulated one. We can use it for the simulation software arcade piece-based. In the same manner, we have to calculate for the concentrated loading with the equal voltage, unequal voltage, radial distribution and ring main distribution. Thank you.